A block of mass m is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. The wedge is given an acceleration a towards the right. The relation between a and theta for the block to remain stationary on the wedge is option 1 a equal to g cos theta, option 2 a equal to g by sin theta, option 3 a equal to g by cosecant theta, and option 4 a equal to g tan theta. Here the system of the wedge and the block is a non-inertial frame of reference. As the system is given an acceleration a, the block will experience a pseudo force ma opposite to the direction of acceleration. And now for equilibrium condition of the block, that is for the block to remain stationary, the necessary condition is the component of weight mg sin theta should be balanced by the component of the force, that is of ma, which is taken as ma cos theta in the same line, should be equal. So mg sin theta should be balanced by ma cos theta. For such a condition, the block remains stationary. So we can simply say that ma cos theta equal to mg sin theta, therefore a equal to g tan theta is going to be our conclusion as a relation between a and theta. So to mention the same thing, the system is a non-inertial frame, and the block experience a pseudo force ma opposite to the acceleration of the wedge, opposite to the acceleration of the wedge. The wedge is as a whole given an acceleration a, therefore the block experience pseudo force ma in opposite direction, and therefore for equilibrium state of a block, for equilibrium, or as mentioned here, stationary state of body of block, the necessary condition is ma cos theta, as mentioned, the component of the pseudo force ma cos theta should be equal to mg sin theta. Therefore a equal to g tan theta. This is the relation between a and theta. So option 4 is our correct answer.